The vector product of two vectors. There are two methods of performing vector multiplication. If you look that up, that's not quite true. There are two methods of performing vector multiplication that you need to know about in this course. A quick visit to ChatGPT will tell you that there are many methods of multiplying vectors. One method of vector multiplication gives an answer that's a scalar, and that's the one we're familiar with. We're familiar with a dot b is equal to mod a mod b cos theta, or that a dot b would be equal to a1 b1 plus a2 b2 plus a3 b3. But that gives us a number at the end, as we've seen before, both when we did 2 dimensions last year and in this 3-dimensional course a couple of examples ago. So it gives us a number, and hence it's called the scalar product. A second method gives an answer that is a vector, and we can only really do this one once we go into 3D, as we'll look at shortly when we look at the geometrical interpretation of the vector product. We call this the vector product, no surprise since I mentioned it just now. For vectors a and b, the vector product is written as a cross b. It's also referred to as the cross product because of the operator, and is a vector perpendicular to both a and b. We'll talk more about that later, but that's why we need to be in 3 dimensions. If we have a vector that's perpendicular to 2 other vectors which are not parallel, then it must extend into a 3rd dimension. We say that a cross b is a vector normal to the plane containing a and b. So we will go into this a bit more later, but I'll just mention it now, that if you have a plane, think about something like your desk, and you have 2 vectors a and b which are in your desk, then the vector product gives us a vector which is perpendicular to those vectors.